Hello everyone, I am Pratiksha Shinde. Today I am going to present backpropagation in a neural network. Now let's see the content that I am going to present. First one is what is a backpropagation in a neural network. Second one, working of backpropagation. Third is advantages of backpropagation. And last is challenges with the backpropagation. What is backpropagation in a neural network? Propagation is also known as the backward propagation of errors is a method used to train a neural network. Its goal is back to reduce the difference between the model's predicted output and the actual output by adjusting the weight and bias in the network. It works iteratively to adjust the weight and bias to minimize the cost function. If each of the model adapt the parameter by reducing loss by following the error gradient. Backpropagation is a method used to train a neural network, especially feed-forward network. It is an iterative process that helps minimize the cost by adjusting the weight and bias. The goal is to reduce the difference between the predicted output and the actual output. Now let's see how backpropagation works. The backpropagation algorithm involves two main steps, the forward pass and the backward pass. The first one is the forward pass. In a forward pass, there are three main layers, input layer, hidden layer, and output layer. First one is the input layer. Input data is fed into the network. In a forward pass, the input data is fed into the input layer. These inputs combined with their respective weights are passed to hidden layers. Next one is the hidden layer. Inputs are multiplied by the weights and add to the bias, then passed through any activation function. This process may occur over several hidden layers. For example, network with the two hidden layers, H1 and H2. The output from H1 as the input to H2. Before applying any activation function, a bias is added to the weighted inputs. Next one is the output layer. The final layer produces the prediction which may be transformed into the probability for a classification task using any activation function like a softmax. The output is a passed to the next layer where any activation function such as a softmax convert the weighted outputs into the probability for a classification. Next is a backward pass. In the backward pass, the error, the difference between the predicted and the actual output, is propagated back through the network to adjust the weights and bias. One common method for a error calculating is the mean square error given by the predicted output and the actual output. There are the some layers they can include in the backward pass. First one is the calculate error. Measure the difference between the predicted output and the actual output using a loss function such as the mean square error. Next one is the propagate error backward. Starting from the output layer, propagate the error back through the network to update the weights and bias. Next one is the compute gradient. Determine how much to change each weight and the bias to reduce the error. This is done using the chain rule from calculate. Update weights and the bias. Adjust the weights and bias used on the gradient and the learning rate. Once the error is calculated, the network adjusts weight using the gradients, which are computed with the chain rule. These gradients indicate how much the each weights and bias should be adjusted to the minimize the error in the next iteration. The backward pass continue layer by layer, ensuring that the network learns and improve the performance. The activation function through its derivative plays a crucial role in the computing these gradients during a backpropagation. In this image, you can see how forward pass propagation works. Advantage of backpropagation. First one is easy to implement. It does not require a deep knowledge of neural networks, making it beginner friendly. Next is a simple and flexible. can be applied to various problems and network structure from simple to complex. Third one is the efficient quickly update weights based on the errors, speeding up the learning process. Fourth one is a good generalization. Have the model perform well on new unseen data. Last one is a scalable. Works well with larger data set and the complex network. Challenges with the backpropagation. First one is the Wishing gradient problem. In a deep network, our gradients can become very small during backpropagation, making it difficult for the network to learn. This is a common when using activation function like a sigmoid. In a gradient become a very small in a deep networks. Earlier layers learn very slowly or not at all. Next one is the exploding gradient problem. The gradients can also become a larger consuming the network to average during training. Gradient become extremely large, weights update to unstable training. Next one is overfitted. It is the network is too complex. It may memorize the training data instead of learning general pattern. In a model mode. Thank you.